Hello, friends. Let's continue with the discussion of introduction to the smart grid. We have already seen the concept, need, and the function of smart grid in the previous section. Moving ahead in this particular presentation, we will talk about the opportunities and the barriers of smart grid in terms of Indian context as well as the worldwide. Wherever, what are the drivers which are responsible for smart grid in the India, the key functionalities and the components of the smart grid, and the major differences between the conventional and the smart grid. So let's start with the opportunities. So from India point of view, the opportunities for the smart grid or the driving forces for the smart grid are first of all the secure and the ubiquitous communication. That is, we have already uh, good infrastructure for a two-way digital communication which is existing. So the same communication can be utilized effectively to have a smart grid. Secondly, we have embedded sensing, automation, and control. That is, the use of automated switches to respond to the real-time conditions can be employed to make a grid smart, and thus this is an opportunity for us to move towards a smart grid. The third is the automated real-time optimization. Now, the active load balancing and the self-correct for the interruptions and power quality issues are already available. So, since things which are already available with us, so this can be inculcated to the existing system, and thus we can move towards the smart grid. Next, the enhanced design and the predictive monitoring. That is the tools to optimize the network planning and predict the response. And finally, the fifth part, that is the distributed generation and demand response. So that is the simplified interconnection standards, two-way power for capabilities, and more effective load balancing techniques. So these are the various points or various opportunities in India which can promote a smart grid. Whereas when we talk about the global opportunities, it's simply firstly the demand. There is an unrelenting increase in the demand. The population is rising, and hence the demand is also rising, and that's why we need to move towards the more efficient grid so that we are able to have energy to everyone on the globe. Second biggest opportunity is to reduce the global warming. That is reducing during at the demand during the peak times and its ability to deploy the renewable energy sources. And the third, that is upturn in the trend in the unit cost of electricity. That is, the per unit cost of electricity is always growing for past many years or many decades. So we have to put a limit to this growth trend of the unit cost of electricity. So these all are the opportunities which is responsible to force towards the smart grid to be implemented. The other opportunities, that is global opportunities, is reliability. The electric utility industry is facing a decline in the quality. At the same time, the unit costs are also rising. So this makes the energy not very reliable for the customers. Secondly, the smart grid will also improve the load factors and it will reduce the system losses. Thus, it will increase the efficiency of the system. And moreover, since smart grid will be integrating more renewable energy sources, so definitely it will limit the greenhouse gases effect and it will improve the environment. And finally, with these things, the cost saving will be there, and hence, in order to save the cost, this is an opportunity for us to move towards the smart grid. So these were the global opportunities which will force us to implement the smart grid. Other global opportunities also include the grid improvement. That is, we need to deregulate the grid, that is, decentralize the grid, and it should not be a self or a private sector, or it should be limited to a particular person or a particular community. Then the technological advances. Since the advancement in computing and telecommunication, it will be little easier for us to implement the smart grid globally. Then the opportunity for us to improve the customer satisfaction, we need to move towards a smart grid. And lastly, that is the electric vehicle. There is more and more number of electric vehicles are being designed and it being put into the system, which will allow electric vehicle to the grid and then grid to the electric vehicle two-way communication and the two-way exchange of power through the grid. Next, moving ahead, the barriers in the implementation of smart grid. What are the major factors which might hinder the implementation of smart grid. The first one is the policy and the regulation. So obviously the regulatory body and the policy makers have to take care of the incentives in the private sector. That's why, so that the private sector are more involved and they are more attracted towards investing in this particular sector. So the policies and the regulations should be a little flexible for the private sector so that they can easily invest in the smart grid, which will definitely help the power sector smart grid implementation, but which is not true at the moment. At the moment, the policies and the regulations which are existing has become a barrier into the implementation of the smart grid. Secondly, the business case. The policymakers and utility executives have taken only two factors into consideration, that is the capital cost and the operating cost, and what is the economical tangible factors, that is the benefit which they will get. They have not considered the business model as a long-term benefit or as a benefit to the environment, which is causing a big problem for the private sector investors to uh, jump into the smart grid as a business unit. So this is again a barrier in the implementation of the smart grid. Then the third is technology maturity and the delivery risk. Technologically, though we are advancing, but are we still mature enough to deal with the kind of smart grid technology we'll be needing? Will be able to deliver the technology into the different stages of the implementation of the smart grid? That is again a big question. Next, lack of awareness. The consumers and the policymakers are unaware of the role of the smart grid in enabling the low carbon future. That is, they are not aware of the long-term benefits of the implementation of the smart grid, how it is going to affect the environment and it will try to nourish the environment in future. Then next is the access to the affordable capital. Still, the stable framework are not been designed for the optimal allocation of the risk between the customer and utility. There has to be and access to the affordable capital to both the consumers and the utility which are going to come into the smart grid implementation. Next is the skill and the knowledge. Obviously, there is a very shortfall of the critical skills which are being required during the implementation and the maintenance of the smart grid. So still, if we talk about the knowledge part, the very less people of the number of people are aware of the exact critical skills which will be applicable while implementing the smart grid. And finally, there is a major barrier in the implementation of the smart grid, that is the cyber security and the data privacy issue. Now, since the smart grid will be having a huge communication network and the data will be transferred throughout, so it will be on the net, and internet is very much susceptible to the security threats and the data privacy issues. So again, it's a very big barrier in the implementation of the smart grid. Now, when we talk about India, what are the drivers? The drivers in the India for implementation of the smart grid. So the first is the shortfall, supply shortfall, or the increasing demand. In India, the demand shortfall is 12% for a total energy and 16% for the peak demand. So we are still lagging behind in the demand of the power in order to give the customers 24 into 7 supply. So it's become a driver for us so that we are able to generate so much of energy to meet the demand, or we are able to implement such a system that without adding any generating units, we are able to suffice the demand. Then loss reduction. India's aggregate technical and commercial losses have been about 25 to 30%, which we need to reduce. So in order to reduce the losses, we should move towards implementing the smart grid. Then managing the human element in system operation, which means wherever needed, we have to reduce the number of human elements involved in the system, because of the human involvement more into the system, the chances of occurring problems or the rectification part takes more time, and so system becomes less reliable. So automated meter reading and the automated system would make the system more secure, more reliable, and it will be having a real-time data availability to us. So thus the human element will be managed into the system. Next, for peak load management. Still, during the peak hours, we are not able to give the sufficient amount of supply or sufficient amount of energy to the consumers. During the peak load, the load shedding is still being employed in India to give the supply to the industrial sector. The next driver is the renewable energy. That is, we are moving towards the solar energy, and by 2020, we will be adding more 20,000 megawatts of energy. So thus, the involvement of solar and the wind into the system will drive us to move towards implementation of smart grid. And lastly, that is technological leapfrogging, which is nothing but moving ahead in the technology. Technologically, also India is moving ahead, and we are having different technologies which will be helpful while implementing the smart grid. Now, when we talk about the functionality of the smart grid should able to do following functions. So, what are the functions are? First of all, to be heal itself. So, in case of any trouble, the smart grid, the grid should be able to heal itself. It should try to recover the problems itself. Second, it should motivate consumers to actively participate in the operation of the grid. Third, it should resist any kind of attack into the system. Fourth, it should be able to accommodate all energy generation and the storage options. Fifth, the power quality should be maintained very high. Sixth, there should be an optimized asset to run more efficiently. All the assets should be operated very effectively. And the last, it should be enabling of high penetration of intermittent generation sources. So this was the functionality of the smart grid. These are the main functionality of the smart grid apart from few others. Now, what are the elements of the smart grid? There are n number of elements. For example, access management system, building automation and control system, distribution automation, distribution management system, energy management system, information and communication technology, load production, power electronics, power quality, security, consumption, generation, smart meter, smart home, substation automation and production. So these are various components or elements of the smart grid which will be integrated together to make a smart grid. Now, in the last section of this particular presentation, we will discuss the difference between the conventional and the smart grid, which we have already have a little look of it. In conventional power grid, you will be having more of an electromechanical type of devices or system which is available. Whereas in a smart grid, you will find more of the devices are digital. The communication in conventional power grid is one way, that is from the towards the source to the load, whereas in a smart grid communication takes place two way, that is from generation to source as well as the source to generation. The generation will be centralized in conventional power grid, whereas in smart grid the distributed generation occurs. There are very limited number of sensors available in conventional grid, whereas there are a huge number of sensors throughout the system in the smart grid. In conventional grid, manual monitoring is most oftenly taking place, whereas in smart grid, self-monitoring capability is there. You have manual restoration system in when you talk about conventional grid, whereas in smart grid, it is self-healing and it will try to restore the system by itself. The failures and the blackouts are the property of a conventional grid, that is, frequent failures and the blackouts can occur in the conventional grid, whereas due to the adaptive and isolated technique, the failures and blackouts are taken care of and it is not being happening in the smart grid. The control on the power system, the conventional power grid is very limited, whereas in power system the control is very huge and its pervasive control is available. And the last, very few customer choices available. The customer has very few choices, whereas in a smart grid, the customer has a number of choices. It can take a number of decisions as per the choices available. So these were the topics into the smart grid. We will further move on to the next topics in the next presentation. I hope you understood this particular section. Thank you very much.